Hello everyone. I am making these series of videos which will cover the key concepts of 12th standard physics as per CBSE syllabus. Today we will start the first chapter in the NCERT book part 1, that is electric charges and fields. And in today's video I will be talking to you about frictional electricity, electric charge and the properties of electric charge. Electric charges and field, as I told you, the name of the chapter is. So, what is, first of all, we should know what is electrostatics. Electrostatics is the study of charges at rest, forces between the static charges and fields, potentials due to these charges. It is called electrostatics or static electricity, or even frictional electricity. So we can call anything, we can call it as frictional electricity, static electricity, or electrostatics, because we are dealing with the study of charges at rest. And along with the study of charges at rest, we are talking about the forces between these charges which are at rest, which are called static charges, fields due to these charges, potentials due to these charges, and the whole thing comes under electrostatics. As we are talking about charges, we should know what is an electric charge. So charge is the property associated with matter due to which it produces and experiences electrical and magnetic effects. So it is the property which is associated with matter due to which it produces electric effects as well as magnetic effects. We all know that there are two types of charges, positive charge and negative charge. There are two types of charges we are all aware of, positive and negative charge. Charges with the same electrical sign repel each other, and unlike charges attract each other. We all have studied in our lower classes that like charges repel each other and unlike charges attract each other. So, if I take a glass rod and rub it with silk, a piece of silk cloth, then we will see that the glass rod becomes positively charged. That means if the glass rod is rubbed with silk, glass rod, when it is rubbed with silk, it becomes positively charged, right? Initially, the glass rod and silk both are neutral. Neutral in it means that it has equal number of positive charge and equal number of negative charge. So the glass rod is also neutral and the silk cloth is also neutral. But when you are rubbing the glass rod with silk, we are producing frictional electricity because of rubbing, and that is why in this process glass rod becomes positively charged and silk in this process becomes negatively charged. Now, why the glass rod becomes positively charged and silk becomes negatively charged? Because the glass rod has a tendency to lose electrons. It has a tendency to give away its electrons faster as compared to the silk cloth because of the term which is called work function. What is work function? Work function, you should understand, it is the minimum energy required to remove the electrons from the surface of the material so that it can overcome the restraining forces. So glass rod, when you are rubbing the two objects together, that is the glass rod and silk, when you are rubbing the two objects, the energy which is required for the glass rod to give away its electrons is lower as compared to the energy required by the silk cloth. That is why it gives away electrons, and when a body gives away electrons, it will become positively charged, and the other body which gains electrons will become negatively charged. So in this process, glass rod becomes positively charged and silk becomes negatively charged. Similarly, if you rub an ebonite rod with a piece of wool, then the ebonite rod will become negatively charged in this process. The ebonite rod becomes negatively charged in this process. Now here in this particular diagram, we are trying to show that like charges are repelling each other and unlike charges are attracting each other. So this there is a glass rod which has been rubbed with silk, which is positively charged, and it is suspended, and another glass rod which is also positively charged is brought near to the suspended positively charged glass rod. What we observe is that the two glass rods, they are repelling each other. You can see the direction of the forces. So this is repulsive force. Similarly, now we have a glass rod which has been rubbed with silk, and there is an ebonite rod which has been rubbed with wool. As I told you, ebonite rod, when it is rubbed with wool, it develops negative charge on it. So these two, you can see these two rods have opposite charges on them. So when they are brought close to each other, you can see that there is a force of attraction between the two charges. So you can see that the forces are attractive forces, right? This force is towards this glass rod and this force is towards the ebonite rod. So the charges acquired by the objects on rubbing against each other are equal and opposite. So in this process, when you are rubbing glass rod with silk, if the glass rod has developed 4 units of positive charge, silk in this process has developed 4 units of negative charge. So the charges which are acquired on rubbing are equal and opposite. And as I told you, the glass rod develops positive charge and silk develops negative charge when you are rubbing the two against each other. Similarly, ebonite rod and wool, when they are rubbed, ebonite rod is rubbed with wool, the ebonite rod becomes negatively charged. And also I told you about the work function. So electrons are transferred from the material whose work function is lower as compared to the material whose work function is higher. So when we are rubbing glass rod with silk, the work function of glass rod is small as compared to the work function of silk. That means the energy required by the glass rod to give away its electrons is lesser as compared to the energy required for the silk cloth to give away its electrons. Okay, so we will proceed now. Electric charge, as I told you, the properties of charge we will talk about. Charge is a scalar quantity. It is a scalar quantity. Charges can be added or subtracted algebraically. That means if you have plus 3q charge and you have minus 2q charge, what will be the total charge? It will be plus q. So this property is also called additivity of charge. Thirdly, charge is transferable. Okay, charge is transferable. That means if a charged body is put in contact with an uncharged body becomes charged due to the transfer of electrons from one body to another. So the charges are transferable. Charge is always associated with mass. That is, charge cannot exist without mass, though mass can exist without charge. Charge cannot exist without mass. Now when we are saying that 4 electrons or 2 electrons are transferred, electrons has certain mass. Though the mass of an electron is very, very small, it is nothing but it is 9.1 into 10 to the power of minus 31 kg. The electron mass is very small, but there is some mass. So when the charge is transferred, there is some change in mass also, but that change will be considered to be small only. So charge is always associated with mass. Charge is conserved. Charge can neither be created nor destroyed. Okay. And the 6th property is quantization of charge, which is a very, very important property. It is the property by virtue of which all free charges are integral multiples of a basic unit of charge on an electron or proton represented by E. So it is the property by virtue of which all free charges are integral multiples of a basic unit of charge on an electron or proton. And the charge on an electron or proton, we are representing it by E. Okay, charge Q of a body is given by Q is equal to NE. So charge Q of a body, total charge of a body, Q is given by Q is equal to NE, where N is an integer which can be positive or negative. By convention, charge on an electron is taken to be negative. Okay, we are all aware that charge on an electron is taken to be negative. And what is the basic unit of charge? It is 1.6 into 10 to the power of minus 90 coulomb. This is the basic unit of charge. 1.6 into 10 to the power of minus 90 coulomb. Right? So when we say that two electrons are transferred, it means Q is equal to Q is equal to NE, which means nothing but Q is equal to, let's say 2 electrons are transferred, 2 into 1.6 into 10 to the power of minus 15 coulomb. That is Q is equal to 3.2 into 10 to the power of minus 19 coulomb. Sorry. So the total charge transferred is 3.2 into 10 to the power of minus 19 coulomb. So the very important question which is asked is, what is quantization of charge and what is the cause of quantization? So what is the cause of quantization? The cause of quantization is that only integral number of electrons can be transferred from one body to another. That means if I say that 2 electrons are transferred, or 3 electrons are transferred, or 10 electrons are transferred, and so on, I cannot say that 1.5 electrons are transferred, right? No, because integral number of electrons are being transferred. That is why we cannot have a charge on a body can never be 0.5 E, 1.72 E, etc. or 1.75 E, etc. So the charges will be an integral number of electrons. Charges can be transferred in integral number of electrons only. So when one electron is transferred, the charge on a body would be 1.6 into 10 to the power of minus 19 coulomb, because one electron has charge equal to 1.6 into 10 to the power of minus 19 coulomb. If I say 2 electrons are transferred, then I have shown it to you. If I say 4 electrons are transferred, then 4 into 1.6 into 10 to the power of minus 19 coulomb. So this is what is a very, very important property of charge. Charge always exists in discrete nature. Okay, the charge always exists in discrete nature. That is, charge is quantized. And what is the basic important cause of quantization? That only integral number of electrons can be transferred from one body to another on rubbing. Thank you. We will continue with this chapter in the next video, and in case there is any doubt, you can post it in the comment section. We will clarify it. Thank you.